We got square root times square root. Answer's a square root. What's 5 times 13?
39.
Nope. That'd be 3 times 13. A couple more. 65. Yep. Now, if that'll break down, we'll break it down. I know 8 squared is 64 and 9 squared is 81, so it doesn't break down, so that'd be it. Easy enough, not too much to that. You do the same thing if it were variables. If I had the square root of 7 times the square root of xy, I would say square root times square root. Yep, I can do that. My answer will be a square root, and then I'll just have 7 times x times y. Okay, nothing fancy. Everybody knows how to do all that. Alright, now let's add some different roots and some more variables. Here we got the 5th root of 9y squared x times the 5th root of 8xy squared. Okay, still got to check, make sure it's possible. 5th root times 5th root. Yes, sir, Bob, your answer will be a 5th root. Then you just multiply underneath your coefficients. 9 times 8, 72. What about your y's? What's y squared? And you got another y squared. Yep, Zane, y to the 4th. And then your x's, you got an x and an x. Squared. Now, sometimes you'll be able to break that down and sometimes you won't. What you look for, in order for variables to break down, their power has to be bigger than the power in the index. And on both of these, 4 and 2 is smaller than 5. So that's a clue to you that you're not going to be able to break it down. And we'll see some of those later where we got to break some junk down in there. Alright, rules are the same when we're looking at division. So if I have cube roots of 18 divided by 125. Okay, when the whole thing's being cube rooted, remember that means you cube root the numerator, you cube root the denominator. Alright, on the numerator, is 18 a perfect cube? Sometimes itself 3 times equal 18. We made a list the other day. Chase is correct. Nothing times itself, no whole number times itself 3 times equals 18. Because 2 cubed is 8. And 3 cubed is 27, so we jumped right over 18, so we're going to leave that like it is. What about 125? Is that a perfect cube? Yes, what is it? 5. So that'd be your answer there. Okay. Alright, now the main part of the lesson is what I was saying earlier when we can break stuff down. In that case, cube root of 18, we said it's not a perfect cube, but there's also not a perfect cube that'll go evenly into it. Okay, this scenario here, I got the square root of 32, and the directions say simplify. If the directions had said approximate or round, we just type in our calculator. We know 5 squared is 25 and 6 squared is 36, so that's got to be between 5 and 6 somewhere, but it doesn't go, it's not a whole number. So what we're looking for, go back to your perfect square list, and we're looking for the biggest one of them that'll go evenly into 32. What's the biggest perfect square that'll go evenly into 32? Now you had 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So I passed it, so it's got to be something above my dotted line there. 5 won't go evenly into 32. 16 will. So 16 is what we're going to use. Now, a lot of people this morning said 4 will. 4 is on my list. And yes, 4 will. But when it's not the biggest one, you're going to have more steps to do. If you'll choose the biggest one first, there's less work. So we're going to say the square root of 32 is the same as the square root of 16 times 2. If you don't know how many times it goes into it, then type it on your calculator. 32 divided by 16.
4.
Okay? No. Now, point in doing that. What's the square root of 16? Yep, so we bring that foe, Zane said, out to play wiffle ball. What about 2? It won't break down. It's not a perfect square, so it has to stay in the house and do chores. And that's your answer. Okay, let's try another one. If I had the square root of 300, is that a perfect square? If you don't know, you just type square root of 300 on your calculator and see if it's a whole number or not. I think you ought to be pretty good at that one. Sometimes a whole number times itself get you 300. No, is correct. So what's the biggest perfect square that'll go evenly into 300? Biggest perfect square that'll go evenly into 300. Look at your perfect square list. Yep, very good. 10 squared is 100, Kirsten. That's 100 times 3, isn't it? Won't that make 300? Now, we did this a few days ago in Algebra 2, and what they got confused on is they want to bring 100 out to play wiffle ball. It's not that you bring out, it's the square root of it that you bring out. So square root of 100 is 10, so that's what gets to come out and play. The other one stays in and scrubs the floor. Okay? Y'all are better at that than me. Say what was?
I think he was wiping tables.
Wiping those tables. Better than scrubbing toilets, I would think. For real.
For real.
Alright, let's do one that's not a cube, or not a square. Let's do a cube, is what I should have said. Cube root of 54. Alright, look at a perfect cube list yesterday. We had 1 cubes 1, 2 cubes 8, 3 cubes 27, 4 cubes 64. So I passed 54. It's not on there.
27.
So my only choices that I'm looking at are 8 and 27. 27 will go into it. Zane's right. How many times does it go into it? Okay, get it on your calculator. Do 54 divided by 27. 2. I think Michael's checking it. That's good. Good. So we got the cube root of 27 times 2. What's the cube root of 27? Well, that one was 2 cubed, or squared. You're right. This one is 3 cubes. So bring a 3 out to play. Leave the 2 in there. Wiping the tables. This is not new stuff, but this, for whatever reason, this is always something that takes a while to grasp. Usually, the people that I've had in both classes, Algebra 2 and Algebra 3, they said they finally got it in Algebra 3. So hopefully that'll be, if you didn't already have it, hopefully that'll be your case. Alright, now when we got variables in the mix. Variables in the mix. Let's look at square root of 25 p to the 7th. Alright, 25 is an easy one. That's a perfect square. It's on your square root list. What's the square root of 25? What's the square root of 25? 5. Now, p to the 7th. To break that down, what we're going to do, whatever root we're taking in this, there's nothing written in the index out here. We know that's an understood squared, right? So whatever root we're taking, we're going to rewrite our variable using that power. So square root means I want to rewrite p to the 7th using squares. So I could write p squared, another p squared, 2 and 2 makes 4, another p squared, that's 2, 4, 6. I got to go to 7 because my p is 7. So there, 2, 4, 6, 7. That's the same thing, right? Now what happens when we did this yesterday, what happens when you square root a squared? Or cube root a cube, or fourth root a fourth? Yeah, boy, when the root and the power are the same, they cancel out. So that's going to happen on all 3 of those p's. Which means p, other than you really got a p, means a p cubed comes out and joins the wiffle ball game. The only thing left inside is that little old p to the 1st. How about it? How about it? Alright, this one we got says negative 4th root 32 a to the 5th, b to the 7th. All right, first question we had to talk about in the morning class is this one even possible to simplify? Yes, it is. Very good. Some of them said no in the morning because of the negative. That negative is not underneath the radical. If the negative were underneath the radical, then no, we couldn't take an even root of it. But it's not. It's just out in front. It just means our final answer will have a negative thrown out in front. All right, is 32 a perfect 4? Let's see. 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2 is 16. 3 to the 4th, 3 times 3 is 9 times 3 is 27 times 3 is 81. So there was no 32 there. But that'll go into it evenly, won't it? So this is going to be the same as the 4th root of 16 times 2. Now what about a to the 5th? That would be a to the 4th times a, wouldn't it? Why did I choose 4th? Why did I write a to the 4th times a? Yep, because it's 4th root, and we know those cancel out. Chase has got that. So b to the 7th, if I want to write that as 4ths, it'll be a b to the 4th. And to make 7, it's 4 plus 3, so a b cubed. All right, so we got negative already out there. What's the 4th root of 16? We wrote it over here. 2. Done with that. Can I do a 4th root of that 2? No, it's going to have to stay under the house. Hold on to it. What's the 4th root of a to the 4th? No. What's the 4th root of a to the 4th? And wait as long as we need to. 4th root of a to the 4th. Yep, thank you, Mr. Cober. So bring an a out and done with that. Now this a will have to stay. What's the 4th root of b to the 4th? Yep, done with that. B cubed. Rule is if the power is smaller than the root, you can't do anything with it. So cubed is smaller than 4th, so it'll have to stay. I can't do anything with it. So here's all my stuff outside. Oh, I picked the calligraphy pen. Inside, I still have a 2, an a, and a b cubed. Cubed. That calligraphy pen may be easier to write with. Let's try that.
I use that. It was cool.
Well, maybe not. It was.
A lot easier to read.
I'm thinking it may be. May have to try that on the next problem the whole time. Because it doesn't make it as thick. Alright. Here we got square root of 7 times the cube root of 2. Now this is similar to the problem that we started off the class period with. We had square root times the square root, and we could do that. Our answer was a square root. But this is square root times the cube root. You can't do that. So what we're going to have to do is use yesterday's knowledge of power over root to rewrite this stuff to see if we can get them to the same root. Okay, so remember in here on our power over root, this is an understood 7 to the 1st power and a square root, right? So that would be 7 to the 1/2. Okay, with the 3 cube root, that's a 2 to the 1st. So that would be 2 to the 1/3. Okay, so we know that the roots are not the same. That's the dilemma that we're looking at. So the denominator of those roots, you got a 2 and a 3. What will 2 and 3 go evenly into?
6.
6 is exactamundo. So I'm going to rewrite 7 to the 1/2 as 7 to the 3 sixths. Isn't that the same as 1/2? So 2 to the 2 sixths. Isn't that the same as 1/3?
Yes.
Okay, so that means I have power over roots. I just lost the connection. Means, oh, no wonder nothing went up there. Means I have power over root. So this was Oh, and this isn't oriented.
Just a couple inches high.
Just a little bit. Just a little bit.
Is that to reset?
Yeah, what does they call it? Calibrated?
Last year, teachers used to be doing like every 10 minutes.
Yeah.
He said, I'll take it out.
It's not great. I'm writing like way lower than it's showing up. Okay. So now, that green's hard to see it. So now, how we'll root, these are both the same root. This would be the 6th root of 7 cubed, right? This will be the 6th root of 2 squared. Okay? I don't know what 7 cubed is. 7 of 7 is 49 times 7. Y'all check 7 cubed for me. Thank you, sir. I got 2 squared. I'm a champion on that one. Okay, remember the original problem said we wanted to multiply these. Now this is what blows my mind. Whoa, holy cow.
That would not good.
Okay.
The Lord's message.
Okay. This is what, it probably doesn't affect y'all as much, but to think that the square root, oh, I thought I picked a highlighter, not a crayon. The square root of 7 is the same as the 6th root of 343. That's craziness to me, but it is. And you can check that on your calculator. You can hit the square root of 7 and get a decimal. Hit the 6th root of 343, it's the same decimal. That's mind-boggling. But anyway, the original problem said to multiply. It took us all that work to get them to where we can multiply now. So we got a 6th root times a 6th root, which means our answer is going to be a 6th root. What is 343 times 4? Calculator, 343 times 4. 1372. So all of that was your final answer. That's probably the, that'll show up. That's going to be on your assignment you'll have next week, and that'll show up on the test when we come back from the break. But not as much. That won't be the main gist of it.
That's right. Is any of this going to be on this test test?
Oh. Just get it. I thought it might connect again real quick. Let me try one more time. We just got a couple of different problems there. Alright, when you're doing radicals and square roots, most common mathematical type of problem that goes with these are the Pythagorean Theorem and the distance formula. Because Pythagorean Theorem is everything squared, the distance formula is all underneath the radical. So we'll do one of each of those. Those are the common types of different problems that you'll see. So we had a triangle here that has, we'll say this is 4, this is B, and this is 6. Directions say to find the missing side. Remember our Pythagorean Theorem. Y'all are good at that. A squared plus B squared equals C squared. What is our A in this problem? 4, very good. First period.
Coach Ryan,
Huh?
how are they both 6s?
This is a B.
Alright.
Okay. First period, they said the A could be either one of these, and technically it can, but since I already named that one B, I said let's just leave that one B. So we got 4 squared plus B squared equals C squared. Our C has to be that one, because that's the hypotenuse that's opposite the 90-degree angle. Hypotenuse has to be opposite the 90-degree angle. So this is easy, perfect squares for you here. You got 16 plus b squared is 36. Subtract your 16. B squared is 20. Now you got to undo your squared by square rooting. So this is back to the stuff that I told you was the main point of today's lesson. 20 is not a perfect square because 4 squared is 16 and 5 squared is 25. What's the biggest perfect square that'll go evenly into 20?
16.
Nope, 16 won't go evenly into it.
40.
What did you say? 10 is not a perfect square? Did somebody say it back there? 4, very good. 20 is the same as 4 times 5. What the heck? Okay, square root of 4. Bring that 2 out. 5 stays in the house. So that would be the length of side B, 2 square roots of 5. Square root of 20 is a pretty common one that you're asked to break down. That shows up a lot. That's going to be one that you'll probably have memorized before too long. Me personally, I would prefer a decimal answer on this because if we're actually taking a measurement, and I told Caitlin, start here and walk 2 and 5 square roots of a foot. Yeah, she'd cross her feet and fall over. But if I told her to walk 2 point something feet, she might have a better chance of finding it, right? Caitlin, quit pouting.
I'm not pouting.
I was just joking, and you know that. Alright, good on Pythagorean Theorem. Let's talk about the distance formula real quick. See if I can write the distance formula all up here. Where this is going, distance is equal to square root of. We're going to subtract in the parentheses and add out. Alright, that's the formula, distance formula. We've used that a lot in geometry. How you find the distance between 2 points. D is equal to the square root of. Subtract your x's and square it. Subtract your y's and square it. Add those answers. Okay? So if I had 2 points, negative 3, 2, and 0, negative 4, and I wanted to find the distance between those two. Now, just like Tyler said on the bell ringer, you could make either one of those be the 1 and the 2 as long as you're consistent. Whichever one you use first here, you got to use it first there. The x and y is non-negotiable. The first one is always x, the second one's always a y. I'm going to stay normal for once and name the first one my 1s, second one my 2s. That's a y. Y2, Y2. Alright, so we'll plug this in. We'll have the square root of x2 minus x1 squared plus y2 minus y1 squared. Simplify all that in the first parentheses. 0 minus negative 3 is 3. The subtracting the negatives, adding 3 squared is 9. Plus negative 4 minus 2 is negative 6. Negative 6 squared is 36. Hello. What's 9 plus 36?
45.
So, square root of 45. Alright, let's see. 6 squared is 36, 7 squared is 49. Nope, we missed 45. Is there a perfect square that'll go evenly into 45?
9.
9, very good. Same as square root of 9 times 5. What's the square root of 9? 3. 3 square roots of 5. Okay.
12. 38.
Alright, here's what we've got coming up in the weekend, couple of days before the break. Monday, we're going to do one more new lesson. It'll be adding and subtracting with radicals, so we'll do that on Monday. Tuesday we're going to have an assignment over everything that we've done since the last test. And that grade will still go into the grade book. So some of y'all that are exempt, if you're close and screw up, you won't be exempt anymore. Some of y'all that are close could do good and exempt yourself. But that'll be your last grade Tuesday. Then Wednesday we'll start with study guide and semester test review. You few that are exempt, if y'all don't have days to miss and you're here, you're just going to be here. Okay? Everybody good? Alrighty.